All right, let's see if we can work this one out together a little bit. I'm going to need your help. So we had the composition of a cosine of the inverse tangent of 5/12. And I want to find out what its exact value is. Well, I begin thinking about what's being asked here, and I'll just start with the inside first. What's the inverse tangent of 5/12? Or I'm asking, what's the angle that produces a 5/12? Another way to think about it is that I have the tangent. If you remember our inverse properties, the tangent of theta equals 5/12. So what's the angle that makes that true? Well, 5/12 is positive, and I'm looking for the angle there. So that tells me I'm going to be in the first quadrant. But let's draw a picture. Sometimes pictures might be a little bit more helpful to deal with. So I have an angle. I know its angle, or the tangent of the angle, is 5/12. Remember, that was my y value over my x value. So my x value is 12. My y value is a 5. So I have some point. If I were to line it on our standard notation or standard positioning, I would have the point then of 12, 5. And here's my angle theta. You guys all right? The tangent of theta in this particular case equals my y value over my x, which is 5/12 or 5 over 12. The inverse tangent is just asking us, well, what is that angle measurement? All right, now from here, I have pretty much everything I need. Well, no, I don't. Ultimately, I'm going to be wanting to know what my cosine of theta is. So what's the cosine of this particular position? What I need to find then is, if I know this distance is 12 and that's a 5, I don't know what the radius is or the hypotenuse of this particular triangle. If we've kind of been practicing along, we know that right triangles come in lots of shapes. One is a 5, 12, 13. And if we don't remember that, we can go ahead and remember that r squared equals x squared plus y squared, or the side squared. So r squared equals 144 plus 25. Solve that for r equals 13. Basically, what I was able to do is I was able to develop a triangle to help me find some exact values here. The cosine of the tangent of inverse of 5/12. I'm asking basically, what is the cosine of theta now? And the cosine of theta, cosine was, what was it? It was adjacent over hypotenuse, which would equal, where do I want to put that at? Do I have room over here? 12/13. And there we were able to find the exact value of this composition function. All right, let's try now the one and piece this through. We kind of have an idea maybe where we're going a little bit more with our second example. So I want to begin with is I want to find the angle whose sine is -1/3. So let's go ahead and solve and think about what the inside part of that means. I'm asking for the sine of theta equals -1/3. So where is that true at on my interval that I'm allowed to look at? Well, let's draw a picture and see if the picture helps us out a little bit. Sine of theta is -1/3. All right, if it's negative, that tells me then that I'm going to have to be in the fourth quadrant. So let's go ahead and draw, just for sake right now, I'll draw this arrow in one spot where I'm going to have my theta. It's in the fourth quadrant, so that tells me then that my values of 1/3, that 1 equals, let's see, sine of theta is opposite over hypotenuse, so it's opposite over hypotenuse. My hypotenuse is 3. So the radius in this particular triangle would be a 3. The opposite is a -1. So this distance right here is 1 down at -1. I know then that in this particular case, it has to be the value up the top, which is my y value, has to be negative. So I would have then, if I were to fill in this triangle, I would have an r which is my hypotenuse. My y value in this particular case is negative because the sine or the theta that I'm looking for falls into the fourth quadrant. Sines in the fourth quadrant are negative, so therefore my rise is a descent of a -1. And then I'll just need to find out what that x value is. X value represents, obviously, that distance from right there. How do we discover that? We can discover it by remembering that r squared equals x squared plus y squared. R, in this case, is a 3, so that's 3 squared equals x squared plus y squared, which is a -1 squared. 9 equals x squared plus 1. 8 equals x squared. X equals 2 root 2. Now I was able to find all the significant points within the standard triangle. I'm wanting to know now what is the cotangent of this angle. And the cotangent of that angle was the opposite of the tangent. So it'd be the x over the y. And my x is root 2 over a 2. Or a 2 root 2 over my y, which is a -1. So my final value is a -2 root 2. And there's the exact value of the cotangent of the inverse sine of -1/3. Another way that we can work with the compositions is to see if we can write an algebraic statement. So let's imagine that I have some x that's between 0 and 0 and 1. And I want to write the cosine of the inverse sine of x. Well, let's begin to build a triangle, an acute triangle, if we can, to help us understand what are some of those particular values that we're looking at. Well, x, I realize, is between 0 and 1, so it tells me it's positive. So the sine of theta equals x is positive. So it tells me then that I have something in the first quadrant. From there, let's just go ahead and just build a little bit of information and see what I have. Well, I have a radius of 1 or a hypotenuse of 1. I have a height or a value, says my sine of theta, which is this, equals x. So I have a height of x. And I do not know what my y value is at this point, but that's all right. We can figure that out because, again, we remember that sum a squared plus b squared equals my radius squared. A, I don't know. I'm going to let that represent my value of my x right there. So I have a squared plus the other side squared, which is an x, equals 1 squared, which is a 1. Solve that for a. So the other part of the triangle in this acute triangle, it then is a 1 minus an x squared, the square root of that. Now I have my theta is, so I can reduce this down, and what I'm looking for then is my cosine of theta. And what is the cosine of theta of that particular angle? Cosine theta equals adjacent over hypotenuse. Adjacent is the square root of 1 minus x squared over my hypotenuse, which is a 1, which just equals the square root of 1 minus x squared. And there's my algebraic statement of this particular composition function, the square root of 1 minus x squared.